Where do clouds come from? Every day, clouds race across the sky, gracefully sweeping in only to disappear, their relationship with the sun, land, and sea determining their ever changing form and lifespan. But not every part of Earth's atmosphere is a breeding ground for clouds. As a whole, there are 7 distinct layers of the atmosphere, each with unique properties to protect the planet. The lowest slice transports water in all its guises over land and sea, sustaining the richness and diversity of life. The troposphere, the lowest layer of the atmosphere, is home to life-affirming oxygen, abundant nitrogen, and a small yet vital mix of carbon dioxide, water vapour, and other greenhouse gases. It's here that the weather machine continually flows, distributing heat and water across the globe. The most essential dynamic in this zone is that air cools with height. This dynamic alone allows convection, advection, and condensation to happen, the fundamental tools of cloud formation. This happens at every level of the troposphere, with each part interacting and mixing, sweeping upwards and dipping to the oceans. The recipe for clouds. Ask a class of 5-year-olds what clouds are made of, and at least one will shout out, "Fluff?" And they certainly do look like that. But, in fact, the white stuff that floats in the air is a product of millions upon millions of tiny cloud droplets that eventually battle for space as more ping into existence. Ultimately, they become one, assuming the guise of a white, fluffy cloud. Putting fluff to one side, the basic ingredients for a cloud are water vapour and heat energy. Heat transports air loaded with water vapour into a cooler environment through advection or convection, and then condensation transforms water vapour into tiny water or ice droplets. Condensation nuclei, such as salt and dust, are also a key component of cloud droplet formation. Tiny condensed water molecules gather by latching onto relatively larger aerosols. Condensation nuclei are about 1 micron, whereas these tiny water molecules are in the order of 0.0001 microns. As more water molecules attach, it doesn't take long for cloud droplets to form, each hosting its own aerosol. The lightness of cloud droplets mean they remain suspended and become the body of a cloud as the feed of water vapour continues. Let's look at the cloud-making process. Convection is the rising of air due to heat. Advection is the horizontal transport of heat by the flow of air. Condensation is when water vapour, a gas, cools and changes into water, a liquid. The rising and falling of air. This happens due to the sun when it heats the earth at different intensities. This flow of air that rises then falls recreates large zones of air pressure, which is high, descending air, and low, rising air. These currents of air carry water and heat. It is a perfect energy system that moderates extremes in cold and hot, dry and saturated. Rainforests, deserts, tundra, icy poles, and verdant mid-latitudes exist all due to the Earth's weather system, keeping the planet rich in diversity with blues, greens, whites, and browns, and every colour in between. The cloud parade. A classic setup that plays out across the sky is the weather frontal system, with a warm front, depicted on a synoptic chart by red semicircles on a red line, followed by a cold front, blue triangles on a blue line. Each part of this process has its own clouds and is a good indicator to the observer of which part of the front is currently overhead. With differences in air density, cold is denser versus warm, which is lighter, air masses don't just merge. The warmer air rises over the top of the colder air, where they initially have distinct boundaries before starting to mix. This can be seen in the progressive cloud structure. It all starts with the layered stratiform cloud, before clearing into the heaped, unstable cumuli cloud.